In section 5.1, we look at linear inequalities and their graphs. The process of graphing a linear inequality is actually very similar to graphing a linear equation, which is something we looked at in the first chapter of this course. So, to see how to do this, let's first treat this inequality as if it actually was an equation. Let's ignore the fact that it's an inequality briefly. So the resulting equation would be this: 5x plus 2y equals minus 10. So the graph of this is going to be a line, and the easiest way to find this is by finding the x and y intercepts. To get the x-intercept, I let y be 0, and then that would give me 5x equals minus 10, or x equals minus 2. So I have an x-intercept of minus 2, and my y-intercept is going to be, well, I set x equal to 0, and solve for y, so I would get y equals minus 5. That would be my y-intercept. And so now, connecting these 2 points, I'm going to get a line, and let's see if I can get a, whoops, let me try that again. I'm going to get a line that looks something like this. Okay, so now, for points directly on that line, let's see, if I take any point on this line, and then plug it into the equation, or plug it into the expression 5x plus 2y, the result is going to be exactly equal to minus 10. So, every point on this line satisfies my initial inequality. However, I don't want points, I don't want only points where 5x plus 2y is equal to minus 10. I also want to find points where 5x plus 2y is less than minus 10. So what that means is my final answer, my graph, needs to be not only this line, but also everything on one of the 2 sides of the line. And so the next step is to figure out which of the 2 sides I need to use. So the useful thing to keep in mind here is if I use, like, let's say this side of the equation of the line, then that means every point on this side of the line will satisfy the inequality. If any one point on that line does not, on this side of the line does not satisfy the inequality, then I want the other side. So, all I really need to do is find any one point in the line, plug it into the inequality, and see if it satisfies it. And generally speaking, the easiest point to check is the origin. I want to know if the origin satisfies the inequality. So notice that if I plug in, I'm going to take 5x plus 2y, and I'm going to plug in x equals 0, y equals 0. So 5x plus 2y would be equal to 0. And that is not less than or equal to minus 10. So I end up with the inequality not being satisfied at the origin. So that means I do not want the side of the line that contains the origin 0, 0. I want the other side. So I'm just going to shade the other side of this. And that's going to be the graph of my inequality. Okay, so let's see another example. I have 3x plus 5y less than or equal to negative 15. Just like before, I'm going to start off by treating it as if it were a line, just an actual equation. If I find the x and y intercepts, the x-intercept is going to be 5 and the y-intercept is 3. So x equals, whoops, I got the wrong one there. X equals 5, y equals 3. Those are my intercepts. So then I sketch my line. See, there's one side, there's the other. And now I need to determine if which side of the line I want to use. Do I want this side, or do I want this side? Well, again, the easiest way to determine that is by checking the origin. So I'm going to take the origin 0, 0 and plug it into the inequality. So again, the inequality is 3x plus 5y less than or equal to 15. If I plug 0 into that, 0, 0, then I get 0 on the left-hand side. That gives me the inequality 0 less than or equal to 15, which is a true statement. So the origin works. So I want to include the side of the line that contains the origin. So my final answer is going to be the line I started with plus everything on this side of it. Okay. Two more quick parts to this example. Okay, so here I have 2x minus 3y less than or equal to 6. So I start off by treating it as if it's an equation. My intercepts are x equals 3, y equals minus 2. X equals 3, y equals minus 2. And so then I'm going to draw the line connecting those intercepts. Let's see, so there's one side, and there's the other. Then I need to check the origin to see if it satisfies the inequality. You can, especially after you get a little bit of practice with this, you can definitely just glance at the initial equation, and you can easily check to see if this satisfies the inequality. If I plug 0 into this side, I'm going to get 0. 0 is less than or equal to 6, so it does work out. I do want to include the origin. So I need to shade the side of the line that contains the origin. Okay. Okay, one more piece, one more part to this problem. Minus 6x plus 5y less than or equal to minus 30. So again, I start off by treating it as if it were an equation. And this line, the resulting line, would have an x-intercept of 5 and a y-intercept of negative 6. So a y-intercept of negative 6, an x-intercept of 5, and so I draw the line connecting those points. Okay, I missed a little bit, but that's close enough. And so you can probably tell at a glance that the origin does not work in this case. If I plug 0, 0 into the left-hand side, I get 0, less than or equal to minus 30. That is not a true statement. 0 is not less than or equal to minus 30. It's greater than minus 30. So I do not want the side of the line containing the origin. I want the other side. Okay, and that's it for this example and this entire section.